Hello, my name is Nikolai Gromov. I'm a professor at King's College London. What's important to know for this video, I'm a founder of a Mathematica summer school in theoretical physics. And this summer, due to the global pandemic, as you may heard about, we had to cancel, unfortunately, our Mathematica school's summer school in Bangalore, India. And so I decided it would be probably beneficial for some of you if I record a few Mathematica lessons. I myself use Mathematica on the daily basis for around 15 years already, for my research in theoretical physics primarily. And I hope sharing my experience will be beneficial, at least for some of you. And in this particular lecture, this video, I will cover very basics, something you would do the first once you open Mathematica. And you see this really blank screen without any hints on where to start with. I will navigate you through this frustrating first stage, and hopefully you will be able to develop from there much quicker. So in this video, I will go through the very basics, and then we will end up with some exercises, and solution to these exercises will be presented in the beginning of the next lesson. And sorry about my hairstyle because, pandemic is pandemic, all barbershops are closed. All right, so for this video, I will assume that you have Mathematica already installed. I'm using Mathematica 12 on my MacBook Pro, but it should be all the same across many versions back, and whether you use Windows or Mac, it shouldn't really matter. So when you open Mathematica, that is what you will basically see. That is so-called a notebook, and it has nothing which would suggest you how to start, really. So one thing I normally change, and I forgot to change it back, is in this upper right corner. I normally change it to 150. This just makes the resolution, the font a bit bigger. So that you see by default it will be 100 is a little bit, the camera is frozen, it's hard to read. So I don't know why they have it so small to begin with. All right, so now we are ready to start. Let's do some powerful maths already. 2 plus 3, what would it be? So we have to press Shift Enter to find out the answer. So this is our main shortcut. And let me type it here, and I change the format to text. So Shift Enter for evaluation. So now I have to point out something. So you see in the right side of your notebook, you have this little brackets, right? So this is a little bracket, this little bracket. So what are these little brackets? This actually indicate for us so-called cells. These are important constituents of the notebook, and they can be of a different format as we've seen. So if you go to format, style, and then you can change them to different, to text, to input for something you're ready to evaluate. And also let's make some nice section 1, right? And then I go here, click on this bracket, go to format, style, and then let's say this will be my section. Right. So this is quite convenient because you can also click on this bigger bracket. I don't know if you can see it. Resolution is not that great, but if you click on this big bracket, it will actually collapse the whole section, and it will make this symbol here. So you can also click here. Okie dokie. So let's continue. So what's next? Multiplication, obviously, right? Next by complexity. And I have to point out that in Mathematica, like in other languages, you can just press space bar, and this will automatically create this multiplication symbol. So actually it's not a symbol, it's just a space here. So 5 times 6 times 7, again shift enter, I will compute for us the result. So now something more complicated. Let's do division, right? Division is always quite hard to do. So let's do, say, 104 divided by 2, right? So I can write it in this ugly way, or alternatively, I can do it with control slash into a nicer form like that. Or if you already typed it in the ugly way, what you can do, you can press Command Shift N to convert it into the nice form. So let me summarize this for you. So Control plus divide with a division bar. So actually, I'm not sure about my spelling, but you'll see many spelling mistakes I'm doing, so please don't complain about that. And convert to a nice form is Command Shift N. Right, and so you see it appeared a bit ugly, this cell, because it's not actually in the text, so format style text. And it's still a little bit ugly because of these extra spaces here. All right, so what's next? Say you can also have a square root, right? So 144 is 12, shift enter, gives me 12. So how did I type the square root? Is again SQRT will be control plus 2. So control 2 will create this square root symbol. So more generally, so how can you know all this? How can you find about all these shortcuts? So the way to go is the following. So open this palettes, basic math assistant. All right, so you probably can see it fully here. So let me move it this way. So you see there are already predefined lots of useful stuff here. So for example, our square root. And if you hover your mouse, over this button, you will see the shortcut appearing. You see the keyboard entry, Control 2. So it's a bit small font. Hope you can see. So this is this hint appearing next to the button. So, and you can do many things. For example, let's do pi. So what is pi? Is actually quite important. Is escape, p escape. So let's do escape, p escape, and this is pi, right? So it doesn't do much for us because pi is an exact number in Mathematica, and if you want, say, 1 to see first 10 digits of pi, you have to apply this function n to it. So one important thing to point out, so it's quite non-trivial, Mathematica uses square type of brackets for the functional arguments, not the round, but square. And those all functions, they will start from a capital letter, like here, or even the sine function. Say sine of pi over 6, whatever it is. Actually, it's 1/2. Everyone knows, obviously. Or pi over 12. But the point is, sine function starts from a capital letter, and its arguments are in square bracket. This is something which is, I don't know why this happened, but we have to always remember that, especially in the beginning. I can see many mistakes like that. People are trying to type functions from small with a small letter and use round brackets. All right, so here actually I unconsciously started writing some comment. So use capital first letter for the function name and square brackets, right, for each argument. So So right, so this bracket star is actually used for the comments, right? You can write them and they won't be evaluated, they won't affect anything in the result. So what's important, like pi, we entered escape, p escape. There are many other symbols you can enter this way. So escape, a escape will create alpha, which is not anything defined, but you can use it as a variable and then later evaluate. So that's what it will make. Or you can also actually type something from LaTeX, for example, /infinity, I don't know, gamma, if you don't know how to type it, but gamma you can also type escape, capital G. Escape will make a capital gamma for you. So infinity, you see, will create an infinity symbol, and this is very intuitive. Also, you can find all of the symbols here, but it could take some time, and I personally never use it. All right, so what's next? Let's do something more interesting, and let's create a new section name, new functions, right? And then I go here, or I press format style text, which is command 7 for the future. This is for text, and actually I want not this. I wanted to create a subsection. Basic functions. All right, so first function, list. List is itself is a function, but what it represents a collection of objects. So in a sense, you can think about that as a vector. So in the right, you see different ways of entering this list. It's very actually important. In Mathematica, you'll see it in many different places. So you can also type it by means of this curly type of brackets. Braces, I get they're called. So these two are completely identical. So if I say A and P and ask A equal to B, I will get true because it's actually exactly the same. So and we saw that actually different objects, they can be one can type them in many different ways. So for example, this one is the same as power 155 1/2. They're all equivalent. So how do we know what is the basic way Mathematica represents it inside? So for that, you can apply to that full form. So if you apply this full form, it will reveal that actually the square root of 155 is nothing but power 155 and then rational number 1, 2, which is 1/2. And the same way, full form applied to the one curly bracket 1, 2, 3, 4 is simply the same as least 1, 2, 3, 4. So these two forms are totally equivalent inside Mathematica. And least of 1, 2, 3, 4 is in a sense more fundamental. However, it doesn't really matter because it's much faster to type it in this way. All right, so there are many things one can do with this list. For example, you can also define a list of lists. And what is list of lists? This is actually a matrix. And you see, so if you do that, probably that's not what you will see because you have to change the output format. So let me, in the meantime, my Mathematica collapsed. So that's where we finished discussing lists of lists being matrices. And so if you actually type it in your brand new Mathematica, it's not configured yet, that's not what you will see. You may need to type / matrix form, and then it will actually show it as a matrix. If you want to change it once and forever, and this is what I'm doing, I don't know whether you want to do that, but I actually like it, so whatever. So it's a bit fiddly to set it up, but what you have to do is just type this command. Front end, you see set option, obviously is to set an option. Front end refers to the whole interface of Mathematica. Common default format type will change it to traditional form for all output type of cells, because again, let me move this window a little bit. If we look into the cell format, it says output. So output refers to this type of cells which are created after you press Shift Enter. So output is changed to the traditional form. And then all your matrices will look like matrices straight away. You don't need to do the / matrix form, which is really, really annoying. I know why people want something else. All right, so this M is now a matrix, and you can apply function to like computed determinant, like computed inverse, and you can multiply it by another vector. And vector multiplication in Mathematica is with dot, so you can do m dot m dot m dot m. This will be fourth power of your matrix M. Or you can also compute matrix exponent of M, and oh wow, that's quite exciting. And if you want to change it to a numerical form, just press type shift n. What am I saying? / n, right? So what is this / by the way? So I have to tell you that there are a few ways you can apply a function. So let's say function f, and you want to apply it to an argument 4. Of course, you can write it this way, or you can write it this way, or you can write it this way. So these are all exactly equivalent ways of doing that. So in / n, very convenient at the end of your expression to add it, so you don't need to go into the beginning, put square brackets, and go to the end of your line, close the square bracket, and so on. But otherwise, it's exactly the same as writing n at or n square brackets matrix form, matrix X of M. So what else we may like to do? We may like to create, say, a list of first 100 natural numbers, right? And this will take us some time if we start typing it this way. So the better way is to use a table function. Table function will just iterate through whatever we want. So I just say I will run from 1 to 100. And then create for me a list of these i's. Or I can create a list of squares of all numbers between 1 and 100, or any other function you like, so sine of I square, and say, let's make it numerical with / n. This is what we will get. So this is very important, this function table. You can also create square matrices, so let's not get crazy. Let's just do it 10 by 10. So in some function which is sine of I and j, I will refer to the row number and j is a column, right? So in this case, it doesn't matter really because it's a symmetric matrix, obviously. So you see that's a matrix of sines, which is 10 by 10. And we evaluated them numerically because of the / n, which is exactly the same as I said before as n at, or n applied in the normal way. Whew. Let's say how hard it's typed. It's like brackets around. It's much easier to do //. Okie dokie. So what's next? So you see there are billion of these functions, right? For example, how would you ever know that function plot will plot you a function in some range, right? How would you know that if I haven't told you? So there is actually a way to discover it yourself. You can just type equation mark and then say let's you know something plot maybe something reasonable. So if you press Shift Enter, this will give you some simple definitions, or if you of the plot function, how to use it, and you can get more, and you can go local documentation, and this will really open you lots of examples. It's really brilliant help system, and Mathematica is something we can enjoy. So another way, so say you want some more advanced plot, you can put this star symbol. This is will replace any string, so it will refer to any function which name contains plot at the end. Or if I put another star, it would refer to any function which has the word plot in the middle. So, and when I press Shift Enter, I get all these functions here, and you can start just discovering whatever you want. So I don't know, I know maybe like 10% of this function. So it's plots 3D. Maybe this is something cool to look at. And indeed, you can go here. Okay, let's get rid of Poopsic. Thank you. Thank you for your feedback. By the way, you can subscribe to this channel and also leave lovely messages. So you see this plot 3D, that's what it does, and you can look into the example, and there are more functions to discover. So this question mark symbol is really fantastic. It really allows you to discover new functions of Mathematica every day, and there are a billion of them. So this is something you will need to complete this exercise for today. So now the plan is the following. I know how well it will work. I will just share a screen with you, and scroll slowly through the exercises. All right, so let's try that. So this is the first page. So I just recommend maybe you pause and just repeat. So it's mostly what we've done, covered in the main part of this lesson today. The second page speaks about lists. So just recommend you. So there is a new thing which we didn't discuss, is how to access elements inside the list. And you can also visit double square brackets, and you can also use it to actually modify the elements. Oh, sorry, some delivery. That the third page speaks about matrices, and finally, that the last page is for you to play a little bit with this help system. All right, thank you very much. I really have to take this parcel. Okay, and hopefully you enjoy this lesson. See you next time. Bye.